This next presenter is somebody who is probably the biggest troublemaker I ever met. And if he gets out of line, we should all just, everybody get together and we'll kick him out of the room. Kick him back to Seattle where he belongs. In truth, Bill Beatty is a very unusual person. He was on KeelyNet years ago on the BBS, and he's provided tons of information, very interactive. He's a big hands-on guy. Of course, if you know the internet, you know the amateur website that Bill has, really, really popular. I mean, hundreds of thousands of hits. And he's got a whole section on weird science. Do you understand? Okay. Anyway, Bill is the one that originally put the KeelyNet files on the internet in 1994, and I probably would not have gone for another 10 years if he hadn't pushed me to do it. So thank you, Bill, for that. Anyway, this is Bill's going to do some demonstrations and his perspective on alternative science and weird science. But for today, are you going to do demonstrations today, or are you going to wait till tomorrow?
Mostly tomorrow.
Great. Okay. He's got some really bizarre stuff. Okay, and this is Bill Beaty. So.
Well, first, one of my personal heroes, Richard Feynman, if people have found the book Surely You're Joking, who was one of the builders of the A-bomb. He always started physics lectures saying, "Any questions?" And usually there aren't any, but it's get people in the frame of mind to start thinking of stuff during the lecture. As Jerry said, I was on his BBS like maybe 80. So he's another personal hero, so I'm sort of following in his footsteps. I started an online forum, if you want to put the first one up there. Do I have? So maybe it's the second one there. Yeah. For people who don't know, competitor to KeelyNet is another listserver that's aimed at inventors and hobbyists. It's basically the same subject matter as KeelyNet. There's Earl, and everybody has a lot of fun testing out weird stuff or debating things endlessly. We have flame wars. I basically give them a free rein, so and after it goes on for several days, I'll come in and yell at people. And another one that might not be as widely known, Vortex L, that I wanted as sort of a private one that's not just full of orthodox idiots that are coming in and belittling everything, and that I'll have to be throwing them off all the time. So it's public, but I just don't talk about it. And that's got some actual cold fusion scientists on it, a bunch of engineers, so it's really advanced hobbyists. So check that out. That's on the webpage, but it's whirled away. So if you want to write that URL down. The people from Infinite Energy magazine, if people are familiar with that, Gene Malov, Jed Rothwell, and those guys, they're on Vortex all the time. So if you want to talk to those guys personally, go hang out on Vortex. After starting that, when I got out into Seattle, I later found that there was a group of science, alternative science people doing Tesla stuff and cap discharge. So the second one, or was the first one on the overhead? Seattle group, yeah. Met up with some fairly secretive people, as usual, doing capacitor discharge, looking for over unity, and we were meeting in a big warehouse. This is Dale, Travis, Gary Hawkins, and a whole bunch of other people. He was building big Tesla coils, and the most fascinating part of that was the capacitor discharge stuff. That they got some big discharge capacitors from Boeing surplus and were firing them off, thinking of something to do with them. And I remember seeing an old article on that you could crush soup cans by putting a wire around it and firing a big capacitor through that. So we tried that, and it would crush cold water plumbing pipe nice. And then they got some really thick wall pipe, and we're firing it, and it would crush it so hard that it would bounce. So the pipe, rather than just giving an hourglass waste, would shatter into these birdcage things. And had fun with that for a while, then found that you could distort pennies if you wound a couple of turns around them and fired the capacitor through it. And that was developed by Dale Travis mostly into a coin crusher. And then they started making smashed quarters. You could reduce your cents, or have the same value but less size. And we're handing around crushed quarters. Unfortunately, never figured out a way to mass produce them. They were like selling them for $50 a shot and only making little handfuls of them. And then I saw an article by Peter Grenou about capacitor discharge through water would give anomalous effects. So we tried that, put a little, maybe a half a thimbleful of water between electrodes with this big nylon post with a hole drilled in it. So, because the article said that you could get plasma vortex, so it would make like a big plasma smoke ring shoot out. Fired the capacitor through that while hiding behind all the equipment, and it goes boom, and the nylon thing was gone. But it was like a hail of about aquarium gravel size little pieces. So, but this was totally uncontained. So it was just like a little, maybe like the size of a pop bottle top with a little bit of water in it, and it went downwards as well as out, and took the nylon out. So then a few months later, I had heard, because I have a family and job, so I missed a bunch of the meetings. I heard that they had developed it into a gun that would shoot a plastic slug through a foot thick of clay. So all that's left of that is, I never got any pictures, but here's the plastic slug. It's amazing. It's like totally undamaged, and at the end, if people want to take a look at this later, the paper end that's got a little sticker on it went through a foot thick of clay. This was a drilled out steel thing with a couple of big electrodes in the side, and the electrodes would explode out every time. So firing it through water gives strange energy effects, which I just got a preprint that it's going to be presented in August, I think. So I don't really want to talk about it, but just mention that somebody finally got over unity measurable by firing a big capacitor bank through water with a resistor in series, and then looking at the energy in the resistor. So this is really simple if you're already doing capacitor stuff, because like you don't want to blow your fingers off. So if you're not comfortable using capacitors in high voltage already, it's not simple. But people that are doing capacitor things should be able to throw this thing together and do measurements and prove over unity and capacitor discharge. Then one of the people in the group is into alchemy, and he tried one of the internet suggestions, which I have a stack of handouts that I'll put out tomorrow during the demo. This was that you can get iron out of carbon transmutation. So starting out with pure carbon, all you do is run an arc through it. So it's just conventional carbon arc, big bright light, and maybe about 100 volts and 10 amps. And in the detritus that comes out of that, if you have a real strong magnet, you can pick up little particles. And if you look them under a hand lens, they're silver. And people have done analysis on it, and yep, it's iron. So you can start with very, very pure carbon rods and just make some arcs for a while. And in all the little carbon crap and bits of stuff, you get little flakes of iron, which is totally impossible. And that's showing that there's really something wrong with science today, which some of the people probably have that suspicion in this room right now. Because turn of the century, I think it's Rutherford, I'm blanking on the guy, that pitch blende ore holding up against a piece of photographic film. No, Rutherford, there's Becquerel. I think it's Becquerel. Published that you leave pitch blende ore on photographic film, develop it, it's all fogged. So something weird is going on. So everybody runs out in the physics community, grabs the stuff and reproduces it. And that's basically the start of quantum mechanics. From that little tiny thing, you got the whole revolution in physics. So today, you stick two carbon rods together and it makes iron. That can't happen, so you get sneering, and anybody with any reputation in physics won't try it. So in science, you're supposed to pursue the unknown, but now it's more like everything is supposed to be known, so you have to defend against anyone who suggests otherwise. So that's really screwy. And then during a meeting, we have fun because this discovery was while playing with dry ice and hot water in big cookie tray, So you have that white smog stuff pouring out all over the floor, and then adding high voltage. I had a big piece of 10,000 volt test lead swinging back and forth accidentally across the dry ice cloud, and a whole bunch of parallel lines would appear. What the heck was that? But I had seen this in Electric Spacecraft Journal, Charles Yost's publication, and they had found with a Scalarian photography setup, which is a way to see air currents, where like you can put your hand on the thing and see the shadow of your hand and all the hot air rising. With high voltage, you could see these little lines sometimes. No explanation, just something that's outside of known physics. And here it was. So we might be able to set that up on a table today, or get a bunch of dry ice over there, so either tomorrow demonstrations, or we might have time to show that. So as you wave your hand over this charged plate with dry ice fog on it, and you get all these little lines, and with high enough voltage you can get like 5 feet away and see this little dot in the dry ice, and you wiggle your hand and it tracks your hand like it's maybe going 30 miles an hour at least along an invisible line from your hand to the dry ice layer. And then the most recent thing that's going on with the group is gravity capacitor. If people are on the internet and are following this stuff, there's a file that's been going around for years that if you stack up a bunch of plates of tin and wax paper, and the plates individually are made of little squares, so you're just making a wax paper metal foil capacitor that's supposed to put out a thrust. So this is a lot like the T. Townsend Brown claims, although the thrust that it puts out is supposed to be quite a bit more than Brown ever saw. And then last year, somebody who remained anonymous, unfortunately, said that they were getting that the thing could lift its weight plus 6 kilograms. So this big hunk of metal foil and wax paper would lift itself off the table, and he had pieces of wire holding it down. And so everybody started duplicating this thing, and nobody could get anything out of it. And that's still underway. I don't know if this whole thing was a hoax, which is a problem on the internet. People don't want the men in black coming and knocking on their door to say that they're doing classified, or that their research is military application and you can't do it anymore. So you want to remain anonymous if you're going to announce something. But then hoaxers can just stay anonymous, and you can't do anything about them. They can make all kinds of grand claims, and if nobody can reproduce it, well, you just spent half a year messing with something that was a hoax to begin with. And it's the problem with alternative science, what percentage of it is real versus people fooling themselves versus idiots that are just the same as graffiti people, that you want to make a name for yourself by screwing up somebody else's thing. And last thing that we got into is subverting the minds of the young. Because to create a paradigm shift, it happened sort of naturally at the turn of the century, and there's been a few of them since in the physical sciences. But now the walls against any kind of alternative science are erected so thickly and tall around conventional science that something else has to get through them, that you can build stuff that shows clear effects, all the cold fusion experiments that really work, and they're just ignored. Everyone assumes that you're lying, or that that you're just fooling yourself, and won't try it out. So you can have a whole revolution going on in the background at the hobbyist level. Nobody's going to fund it because the patent office ignores it, because the scientists say that it doesn't happen. So how do you get through that stuff? Well, my idea was to have the kids or develop toys and science fair stuff, so kids can do this on their own. And then if there's no other way to get through the barriers of disbelief, another generation can grow up that has been messing around with this stuff as toys. So the things that are really easy to reproduce, that's what I'm really looking for, rather than trying to make a living off of a free energy device or healing technologies, etc. I want to build toys. So I was already out there just to have fun and found a great excuse to do it now. One of the great toys I came up with, unfortunately it's not alternative science, but it's really strange, and if you talk to a physicist, they'd say it's totally impossible. Is drawing holograms by hand. And this is all on my webpage as a science project. If people haven't seen it, go take a look. It's directed mostly at kids to doing science fair. This started out when I was working at a optics company and looking at, oh, there you go, looking at a car hood in the sun, and it was giving all kinds of strange little highlights, like the deep polish type of thing from the buffing machines make. And I saw a handprint in it floating, which is impossible. It was floating down inside like a hologram. And then after arguing with the guys at work for about a week, I figured out how it worked and that you could draw it by hand by scratches. So what happened was somebody with a dirty polishing mitt polished their black car hood, and it made a naturally occurring hologram. So I don't know if I can hold this one right for people to see it, but this is a like a Rubik's Cube floating down inside. You see that? But well, tomorrow during demos we can get it out again and zoom way in.
Can you all hit the behind the screen? I can turn this on. Put it here. There you go. Right there.
But this was maybe the third one I made. The stuff on the little picture there is a bunch of other experiments. Those are all maybe 3 inches deep inside the plastic, and it floating in as a virtual image. And anybody can do it. These are sort of complex to make it at different depths, but you can sign your name in down inside the plastic very easily. You just need a piece of clear plastic. It doesn't have to be black. You can. That's just for contrast. And use a couple of nails and a little piece of wood, or buy a fancy artist's divider. And the interesting thing about this is, since it's so simple, you don't need any technology. You just need something flat and shiny, like a board that's been painted with black resin. So for a while I was calling this the Prehistoric Holography. If you have shiny things that you're polishing in the sun, without artificial light, because the main reason why I never saw this before is because it's something that's outside, and I'm spending all my time inside of a building in front of a terminal in artificial lighting. So if it was 10,000 years ago, you could have easily done this stuff right just as you can do it right now. The kids can do it. So I'm wondering if there's like some ancient Egyptian artifact in artificial lighting in some museum right now that looks like it's got sandpaper marks on the front. And no one would ever know it was a hologram unless they take it out in the sun and tilt it around and find the image. But that's just pure speculation. But it's the kind of interesting thing that it's something that could be lurking in museums waiting to bite somebody, that ancient peoples knew more than we give them credit for. So if you believe in ancient technologies, this is something to go looking for, whether there's any ancient holograms hanging around. Oh, and another, let's see where I am. Another little invention, quick demo is, yeah, it doesn't matter, as long as it looks good. What this country needs is square wheels. While messing around for a science museum exhibit on rolling objects, I found that you can take a cube and carve it a little bit, so on end it's a perfect circle and rolls perfectly smoothly when used as, like you can make 4 wheels on a little car. So yet another weird science toy. Until you see it, you can screw with conventional scientists' minds saying that there's a way to make square wheels. Which brings up a point on the web page and the people in the Seattle Weird Science group of philosophy. What I've seen a lot of is scientists versus engineers. Scientists don't want to touch weird science, or not engineers versus inventors. So scientists versus inventors. The inventors will do all kinds of stuff looking for a buck. You want to make a living. And the scientists want to get recognition. So if you're a scientist, your reputation is as precious as gold to you. So you don't want to do anything that gets you laughed at. So there's very few real scientists in the alternative sciences, and lots of engineers, lots of inventors, but you end up with a biased philosophy where you want to patent things, but so you can sell it or start a company based on it. But if it's something that scientists say doesn't exist, then the patent office disallows it, and you have to do trade secrets. But then it ends up being something that doesn't spread around, and people can't basically do riffs on it. Take somebody's cool idea and use it to make something that's 10 times cooler. If the cool idea stays secret and is spending years trying to get it into making it a company, then the cross-pollination and developing a community around a new discovery just doesn't happen if it's in the inventors and engineering side of things. And what's the thing with scientists is, the good side is that they already have funding. What they want to do is get recognition by spreading their cool stuff around. So my philosophy has always been more on the sciences side, but then I have a normal 9-to-5 job, so I don't have to depend on my discoveries and work for making a living. So this is all a hobby. So I can put it all on the internet. So if this could be $1 million toy, or even a $250,000 toy, or a $10,000 idea toy, well, I think it's more worthwhile to put it on the internet for kids to go, wow, and screw with their teachers' minds and just break down their barriers of disbelief and get creativity going by giving all kinds of stuff away free. So any kind of free energy or anti-gravity effects that I find are going right in the internet. And if I get off my butt and get ambition, maybe I'll start a company based on that. But rather than keeping it secret, do like the scientists, at least they give lip service to doing, is publishing everything and having totally free spread of information. So things can catch fire and go all over the place, rather than your first priority trying to protect your idea so you can make a living using that. Oh, any questions? I'll have some more time at the end, but when hecklers are encouraged, you can just yell stuff out if you think of something. And the current thing that I'm just starting to mess with is a few years ago, I was talking to an engineer at a testing company who mentioned that he went to a electrostatics convention, and a 3M engineer mentioned seeing and experiencing a solid invisible wall at a manufacturing plant. And I put this on the internet on my webpage for other people to mess with, and so far, since it takes some doing to set this thing up, no one's tried reproducing it, so I'm going to try to make a little 2-foot across model. But David Swenson, engineer at 3M Corp, was called in to a plant in South Carolina where strange things were going on, and they wanted him to make them stop. It was basically Scotch tape, polypropylene film, 20-foot roll, about 3 feet diameter. That's the one on the left there, that is going up and across and down, maybe like a 20-foot cube, and coming off, being split up onto smaller rolls. So they have these giant ones that came out of the plastics production, and then they break them up into, I think, 5-foot long chunks and ship them to other plants to make Scotch tape. And it's going at 10 miles an hour. And if you get near it, giant sparks come out and zap you on the butt. And your hair stands up so violently that it's painful. So, but the other thing was, if you walk through this tent-like thing, something stops you. And the workers didn't want to get anywhere near this thing or run it, so they called in their electrostatics expert to put in some remediation to get rid of it. But he found that, yes, indeed, you walk through that thing and you get halfway into the middle and you just stop, like you've hit a solid wall. What the heck is that? And he said, it's like Star Trek technology, and they didn't know whether to sell tickets or cure it. Now, if I saw that, I would think, here's the key to breaking through the whole paradigm shift thing. It's something that scientists can't ignore. But this was a manufacturing plant. They got rid of it. So it's the same equipment is still out there. If we had some bucks and probably have to have like a university behind you to go out there and have them take off the discharge combs to get the effect to come back. But like, what happens if you could turn the whole thing on the side? Does it act like a flat, invisible plane that you could stand on? Do you have like an anti-gravity effect? But it's something unknown. So now I'm going to see if I can build something that's maybe like 2 feet long rollers. See if that does anything strange, like making force fields. Because if people are looking for Star Trek technology, well, one way to do that is to accidentally stumble across it. There it is, but do you just get rid of it and never think twice? And it's, of course, not part of physics, so scientists aren't going to touch this stuff. They know it can't happen. People must have been delusional that saw it. But here's another chance for people with a big garage hobby in alternative sciences. Go out and build the thing, see if it does anything that's inexplicable.
What's the question?
Is there muscle paralysis associated? Yeah, what he described is that you could walk along and you could feel all kinds of corona stinging you all over your body, and when you got to halfway, you just go boom and stop, and like it was a puffy wall. And he said that he couldn't turn around. Also, that it was like a force was locking him into place when he was against the wall, and that he had to back up a couple of paces before he could get loose from it, and then walk away. But I think this was, he said it happened years and years ago, and I was talking to him, I think, like 96 or so. So they weren't that curious about it and didn't write stuff down or take pictures of it happening or try to measure how thick the wall is. Or I said, like, throw baseballs at it, see if they bounce off. And it never occurred to them. They got rid of the effect so they could go back to work. So like you discover the key to everything and look right at it and get rid of it because it's in your way. Yeah.
It sounds a lot like what Bob Lazar said. Can you come to the mic so that we can get this on tape?
Bob Lazar, famous for his supposed S4 work. I've done a lot of research on what he supposedly was working on, and static electricity seemed to be a huge component of what they were doing. And, what Tom Bearden has said, do you think, potential in static electricity might actually have some kind of force effect that may be going on in this?
Oh, definitely, because in static electricity, the problem with the field, as a field of research, is that they were going great guns up to the turn of the century and then discovered radioactivity. And everybody who was getting funding and working it through universities, professional scientists, they all jumped onto high-energy particle physics, declared electrostatics finished. But there's the same problem in electromagnetism as well, that they hadn't exhausted the vein of new research in those fields. It's just that everybody had jumped onto the other thing, and then they say in hindsight, well, there's nothing important out there. Well, it's not that they had stopped finding new stuff, it's just that everybody had suddenly lost interest because they found a toy that was even more shiny. So I think, electrostatics, there's probably all kinds of weird things lurking that science has no clue about.
Thank you.
What benefit could this have? The classic response, I think, is from Michael Faraday is, what use is a new baby? Because when it grows up, it could be tractor beams, stuff that's like anti-gravity, lifting objects without touching them. An old science fiction concept is the zero-G bed. You can start like a whole business in porno magazines of levitation beds where you hang in space in your bedroom. And Oh yeah, if it's got health effects, then then it's going to end up like. Oh yeah, well that was one of the things that they saw that when you get corona discharges, it's the same as touching a big Tesla coil, that you get the little purple flame things shooting out, and if that's part of the effect, then you can't expose it directly to people, and it's the same as radioactivity that it's destructive to living things. So here's a new piece of science. If that's indeed what it is, a new piece of science, that it might be something that the uses it won't be in people's houses. Yet if it's 100 years from now and you do have Starship type stuff, it's tractor beam type things and force fields. Maybe it can be developed into propulsion, or a way to lift an object 500 miles up. Then you start thrusting sideways, so you could launch spacecraft if it could be developed to go over long distances. Or maybe it's just something that causes paralysis, which is a known effect, that in the high voltage with little currents going all over your body, maybe it just makes you freeze. Then it's not nearly as interesting. It's just like a stun gun type thing that's going on.
I was on a website, it said a housefly. Remember that? A housefly was caught in it.
I reread that, and no, it was in the high-speed plastic that caught stuff. So yeah, I thought he said that it was caught in the field.
I thought it'd be a good bug catcher.
Yeah. No, but it was actually that he saw stuff being sucked into the high-speed moving tape, the giant sheet of plastic.
That's where the housefly was.
Yeah.
But in your picture, you show there reminds me a lot of a Van de Graaff generator.
Oh, that's what it is, basically, yeah.
It just mainly, the spool that they're spinning. So maybe it's just a new Van de Graaff generator.
Yep. And I think it should be generating immense quantities of ionized air. So that might have something to do with the fact that maybe the wall is actually made of charged air that's being held in place by static electricity forces. But it needs to be reproduced, and I hope that it doesn't have to be as big as that 20 feet across thing before you start to see the effect. That it might be something you can do on a tabletop, but that's the next thing on my list to find out. Next is on my website I have a big section on closed-mindedness in science and the psychology of scientists and skeptics. Here, first quote from Max Planck, talking about his teacher in 1874. So 1874, that physics is basically complete. That it's, as a whole, the system's fairly secured, approaching visibly the degree of perfection, which, for example, geometry had already had for centuries. And then 1888, Simon Newcomb, famous American astronomer, so he's basically like the Carl Sagan of the turn of the century. We're nearing the limit of everything we can know about astronomy. And the next one. 1894, here's a famous quote from Michelson of the Michelson-Morley experiment. He also measured the speed of light at the turn of the century and invented a bunch of stuff in astronomy equipment. This was while he was dedicating a new science lab at the U of Chicago. The more important fundamental laws and facts of physical science have all been discovered, and these are now so firmly established that the possibility of their ever being supplanted in consequence of new discoveries is exceedingly remote. Our future discoveries must be looked for in the sixth place of decimals. So this was just before Becquerel found the fogging of film, and Roentgen found the X-ray tube, and all of the radioactive particle physics science took off. So everything is done, except then you find a little chink in the armor of physics, and everything, all hell breaks loose until the scientists are able to patch that up and then say everything else is finished. Lord Kelvin, one of the big-name physicists from the turn of the century, there's nothing new to be discovered in physics now. All that remains is more and more precise measurement. 1900. One more. So many centuries after the creation, it is unlikely that anyone could find hitherto unknown lands of any value. That's one of the list of objections to giving money to Christopher Columbus that the Spanish Royal Commission came up with. So 1400s. Everything's done. We don't have to go looking for any weird stuff. Or if somebody reports weird stuff, you know they're hallucinating because everything is finished. All new discoveries have already been discovered. So this is a strange part of the psychology of scientists. And I have a big stack of these quotes if people want to find my handouts at the end. The idea that science is at its end and everything is 99% known. And there's a book out, The End of Science by John Horgan. A physicist actually complained about this, that pointing out this problem that for centuries scientists have been saying everything is discovered, and coined the term for this. So here's a little piece of ammo to use against the skeptics. Horganism. If you meet a scientist who discards new discoveries and all of alternative science on the grounds that everything is done, that's Horganism. And another term to use in the battle against conventional science is skeptics aren't truly skeptical. And I came up with the idea, pathological skeptics, one of the former heads of PsyCop, the Amazing Randy organization, he quit in disgust after finding out what they were all about and labeled their behavior pseudo-skepticism. So people that badmouth stuff and attack all of the parapsychology and paranormal, free energy, anti-gravity, everything, attacking it as delusion, they're pseudo-skeptics. They're not true skeptics. Or I like to call them science bigots. Some people call them cynics. And this is very interesting psychology once you recognize what's going on. And there's a lot of material in other fields of psychology that basically apply exactly to what skeptics are doing. That true skepticism doesn't have anything to do with what this is. Prior disbelief is main symptom, otherwise known as prejudice. It's a religious position. If you know that parapsychology is all garbage, there's no paranormal, there's no life after death, there's no possibility of anti-gravity or free energy devices, how do you know that? Because those are new discoveries. Well, if you're a pseudo-skeptic, you know that for a fact. You don't have to question it. But it's that's what prejudice and religious positions basically entail. And then you have people who are insecure often adopt a position of haughty superiority and contemptuous regard for anyone who contradicts what they believe. But scoffing and disbelief is not skepticism. Next one. And I came up with some characteristics of the ideal researcher. If a skeptical scientist you think is supposed to be sneering in contempt of what new discoveries come up, well, the ideal one I think should be childlike curiosity, really, really open-minded because you're looking for new stuff. So if you confront the unknown with preconceptions, you won't see things that are staring you right in the face. And new things are by definition weird. It's the stuff you already know that's well known and safe, and you don't have to think about it too much. So the stuff that's weird and strange, well, a true scientist, that should be their bread and butter. Expanding knowledge, finding stuff that isn't already known. Brainstorming, you're supposed to be having crazy ideas if you're a real scientist, not bad-mouthing crazy ideas. A big part of science should be being a seer, looking at stuff that everybody else looks at and doesn't see something, but you look at it and find a new tack at interpreting things. That's where new discoveries lie, that everyone's been looking right at it and didn't see it. So the more spiritual side of reality, creativity, that's a major component of science. Seeking out strange phenomena, loving the unknown. But a real scientist is supposed to be a skeptic. Last one, or almost last one. the old definition of skepticism doesn't have anything to do with the amazing Randy and Psycop and debunkers. It's just testing things before accepting them. It's very simple. So if you're not testing something, then you're not a skeptic. And the Psycop crowd, they don't test things. They already know what's what, so they can go out and attack a new discovery, debunk cold fusion, etc. And the other part is not fooling yourself. And let's skip that. Skip the next one. Just a couple of quotes. Last one. And I found a great concept in a book called The Encyclopedia of Ignorance. It's your beliefs should be like a bead on a wire that can slide back and forth. If you ever get to 100% belief or 100% disbelief, the bead falls off, and then you're stuck. And to get back to a sensible perspective on things is almost impossible. That people would rather die than revise 100% beliefs and disbeliefs. So if you're always a little bit unsure of everything you know, that's the attitude of a true scientist, not to get stuck in something that if it proves wrong, it's going to wreck your whole life. Well, you drop a rock and it falls up. Well, if you say, well, you had a tiny, tiny belief that maybe that happens sometimes, then there's no problem. But if you're a conventional scientist stuck on this thing where the bead can fall off, if a rock falls up, you go off gibbering into the insane asylum because it destroys your whole worldview. And if that can happen, anything can happen. Well, if you have your bead still on the wire, anything can happen. It just has a very low probability. And that's it. And I think I run out of time for questions. Maybe we can take one quick.
You still got 2 minutes for questions.
Okay, a couple of minutes for questions.
To the mic.
And tomorrow I'm going to be demonstrating the carbon transmutation. We could try to make some little silvery flecks that stick to magnets, starting from very pure carbon rods. I got some electrostatic motor to show off. Everybody can take a look at the plastic holograms. And I have a electricity device, teaching device that I came up with. And I think if I have some table space, I can demonstrate here the dry ice before our dry ice all evaporates, that you wave your hand above a charged plate and see these strange threads of something or other that come out of your body.
You do that,
Yeah, afterwards. And that's it.
We have to kind of cram things together this afternoon, so we've got 5 minute break. We come back to the next one, which is me. I'd like to announce the next speaker. This is Bill Beatty, runs the amateur science website, and he's going to do some interesting experiments. Bill Beatty.
Throw the switch, Igor.
First off, a cute trick I accidentally ran across. I was working in an optoelectronics company, part of Cutler Hammer, and we had all this infrared filter material around. And I had a big sheet of it at night, or about 6 o'clock at night when it was all dark outside, but you could barely see the sun, and held it up to the window and waited for a while, and I could still see the sun brighter. So a few days later, I cut out a piece that would just barely fit onto my eye, and I could mash it down and block out all the light. And at the same time of twilight, where you can't see the ground, but you can sort of see the sky glowing on one side, put that on my eye, and the whole sky was lit up. And after about 10 minutes, I could see the grass. So I made some infrared goggles. It's just infrared filter material, and you can use theatrical gel if you get Congo blue and red and stack them on top of each other. And this is Well, it's mentioned on the website somewhere, I think. If not, I'll have to go write it up. Non-electronic infrared viewing. It's not sensitive. It's because what it's doing is wiping out all the visible spectrum. So you have infrared filter material and you have your visible spectrum, and where they overlap, it's questionable whether it's infrared. And some people would say, if you can see it, it's not infrared. So in bright sunlight, the frequencies that are getting through this are way, way, way too dim for people to see, unless you wipe out the visible. And then the little edge that's normally too dim to see, but it's still there, you can start seeing. So blocking out the visible, letting through just the tail end of the infrared that you can see. If you go outside and wait 5 minutes until you get used to the dark, like right now, all I can see is these stage lights pointing at me. But you can see the grass is like frosty cherry powder, cherry drink mix red, and the sky is really deep blue, and car taillights and headlights are blazing, even though everything looks like it's twilight. So it's a really eerie world, but it looks a lot like color infrared photography, but you're seeing it directly with your eyes. So little weird science project. One thing I heard about was that spandex, like black spandex, is transparent to infrared, and Sony had to change their video cameras because you could see through swimsuits that were made of particular materials, and you go down to the beach with your video camera. I never tried that to see if these are the infamous X-ray specs that everybody has been wanting ever since they were a kid, and the back of comic books. But you make yourself some. These are just welding goggles with a little removable lens, and I cut circles of the plastic material. And you be first. See if. This stuff is a different thing, but I also did the same thing with Congo blue. That's you can barely see through it. It's really, really deep blue filter gel for stage lighting, and red. And I put a couple, 3 layers of Congo blue and 2 or 3 layers of red, and it gets really dark. But infrared camera, if you look at that stack with an infrared camera, it looks like plexiglass, clear glass. It's just invisible. And it just lets the tail end of infrared through. And I don't know if it's safe, so if you go and stare at the sun and you see this little dim glowing thing for half an hour, and then the next day you're blind, don't complain to me, because I've never tried that, so I don't know if it lets a lot of UV through, and it's opening up your pupils a whole lot, and you're out on a bright sunny day with your pupils dilated like this because it's pitch dark inside these goggles. So, so be careful. It's but bright sunny days is when it's best, but then don't stare up at the sun. And something that's definitely on the website. Here it's science and it's weird, but it's not unknown physics anomaly or anything. This, when I was working on museum exhibits years ago, for the electronics exhibit, I knew about this Kaleidoscope Effect, where if you stick a triangular kaleidoscope against a surface, you get infinity off into the distance. And if you tilt the mirrors out a little bit and make them into triangles, it becomes a sphere. So I was going to have this giant thing in the electronics exhibit with a rear projection screen showing slides, and it makes a geodesic dome. And then you can put patterns on it, and all the little triangles have the same pattern. So it's quite pretty. You can have this giant dome with all this changing stuff on it. So I had these kicking around the office, and pretty quickly I put it on my arm, and I have this flesh sphere covered with hair. And that was the day that this got named the Disgustoscope. But if we can pick it up on the little remote camera here.
Wait a minute, let me get focused.
Focus.
Oh my gosh, it's an eyeball.
Ball of eyes, eyeball. You haven't seen nothing. So that's an article on the internet, what the dimensions of this thing. Get some plexiglass mirror and cut it out. And I've had little kids, you'd think little kids would love this thing, but I've had little kids that say, they play with it, they put their hand on it, and I say, no, you're supposed to go like this. And they sort of go, and then they won't look at me the rest of the time, like, you did bad things to my head. Okay, some closer to real physics here, and this is the one that we want to do the camera over here. Nothing up my pipe, big heavy wall copper pipe. It's like this is about $20 worth, and I got a few cheap ones over there if people want to do this at home, and a neodymium supermagnet. And then if I'm really quick, I can whip my hand around and catch it when it drops. And this is a well-known physics exhibit, except they always used copper plumbing pipe with a slip-fit magnet, and it goes about this fast falling through the thing. It's by electromagnetic braking. But a guy I worked for had this big, heavy copper pipe, and we found that with the supermagnets, it was a museum company, so we had weird stuff hanging around the shop that you get this effect. And this is just the interesting thing for an audience. What we really want is you have it in your hand so you can see what's going on, because
Let me get the focus right here, just a moment.
okay,
Go for it.
it doesn't touch the walls, and if it's tilted the slightest bit, it rotates
Let it drop on the paper.
rotates end over end.
Go sideways so you can see it slow fall very bottom.
Let's see if I can get it right down the middle. No, it's still bumping. But Alaskan Copper has this stuff if you want to contact somebody in the Yellow Pages. And sometimes you can find it scrap at brass and copper type places. This is shipboard high pressure pipe. And just regular copper plumbing pipe will work if you get a magnet that's got a little bit of clearance around there. But then you can't see anything. It's just black. But it does the same thing. It doesn't touch the walls, and it slides really slowly. But what's going on is that we have a shorted generator. As the magnet's going down, it makes maybe 10 or 50 amps in a circle ahead of it, and opposite current behind it. So this is the winding of the generator, and here's the moving magnet. And it's just the back forces, because it's a shorted generator. The copper is going to be getting very slightly warm, just as if this thing was sliding along something frictional. And if you move these things back and forth like this, you can feel a big drag without touching, with like a 1/16 of an inch clearance or something. It feels like syrup. And if you motorize it, which I've done before, is chuck it in a drill, a plastic thing with some of these magnets, you can actually heat the copper up. It's got huge currents and eddy currents in the copper. And a similar toy, I don't know if we're going to be able to get this one, but yeah, you have to get it from above. No, I can just do it right here. Copper plate, I've made it into a big adult top here. And if I get it spinning straight, I can do weird things to it without touching it. By putting a bunch of neodymium magnets, and aluminum works just as well for this one. So this is sort of like the end machine, that as it's moving, it's making two big loops of current that they also have their own magnetic field, and you get braking and you get thrust. And this type of thing you can do maglev with. If you have pairs of discs, you can levitate a magnet in a little cleft with the two discs counter-rotating. I think somebody patented that. They had it at one of these similar conventions about 5 years ago. Okay, when I was doing science museum stuff years ago, I got involved with elementary school textbooks, because for the electronics exhibit, I wanted to see how school teachers taught electricity. So I got a big stack of textbooks and went through it to see if I could get some good ideas. And the whole thing in the book was wrong. I picked the next book up, and there'd be 10 errors in one little paragraph on each page in the explanation of electricity. And nowadays, this is well known. You get newspaper articles about how bad textbooks are, that it's all politics, and there's nothing controlling how many errors are in the book. The teachers can't complain because the school system or the state buys the books, and there's no feedback system to keep things accurate. But after looking at these, I started having weird things happening down in my brain, because half of the stuff in electronics that I thought I understood was the mistakes I was seeing in the textbooks. because I was an elementary school student, and the books said exactly the same thing years ago, and then became an electrical engineer, amateur in physics, and I still believed all that stuff at one level. But then in engineering, I knew all the equations that say how it really works, but I had no verbal or picture intuitive type descriptions of electricity. I just had the equations. So I could design stuff, but if I tried to explain it, I would use the elementary school textbook stuff that was wrong. So for the exhibit, electronics exhibit, I started looking for some way to make pictures of how electricity really works. And our initial phenomena here is little hand crank generator and a 6-volt light bulb. Crank the generator, light bulb lights up. This is like if you crank it at maximum speed, it's 8 volts DC. And what I came up with to show electricity is an electronic electric current meter with a chase light device. So the little LEDs there's like every fourth one is lit here, will move along as when there's a current. So these are mimicking how electrons actually move in a wire. A wire is full of free mobile electrons. It's just the copper, the outer electron of copper. When you make copper metal, the outer electron breaks loose, starts orbiting all through the copper constantly. So that's just, right now it's happening. All of this stuff is like electric fluid. So this is like the old Ben Franklin electric fluid analogy, but it's true. It was never disproved. They just started talking about charge. Charge is the modern name for the 1700s name electric fluid. So wires are always full of electric fluid, and a generator is a pump, and electric current is proportional to the electron velocity. So here's a wire with the electrons flowing in it. And since it's shorted out, this is acting like a real wire. You get a really high speed for just a little bit of motion. So let's put our light bulb in series. So we're going to get milliamps instead of amps. Nope. Let's turn the gain. Oh, it got turned from when I last used it. Ugh. There we go. Light bulb lights up. It would be nice if we had lots more LEDs so it would go through the whole circuit. And there's going the other way, and here's AC. So when we explain electricity, something's wrong if we're not saying that wires are made of electricity. It's one component of the wires. It's the mobile electrons of metals. And I just so happen to have it set up so I have two wires. And this is to make kids think. Because we put energy into one end and put a light bulb on the other end. And if we're sending electrical energy to the light bulb, where it's converted to light and flies off and is lost to the environment, what's going in a circle? Let's see if you can see that light bulb. And I put my generator on the other end. Now this has been through the luggage in the plane. I hope that both sides are still working because I didn't get to test it. Oops, I bumped it. It's got this big zeroing knob. There we go. So electricity always travels in a circle. None is lost or gained. Can't create it or destroy it. The light bulb lights up when I crank the generator. So this is like a clothesline a round clothesline with two pulleys that you can turn one pulley, the other pulley turns instantly. Energy is going from one end to the other, but the stuff that moves, that's like the belt. That's like the rope in a clothesline. So I'm the electric company. I sell a pumping service. And if I could do it at 60 hertz, it would just glow constantly. And so the electricity is already in the wire. It's part of the metal. It's always there. The electric company is making it vibrate at 60 hertz. It's like a tube full of water. They're sending sound waves down. So a good way to understand it is air, when you talk, the air vibrates, but the sound goes fast. If you have a tube full of fluid, air or water, if you yell into one end, waves go down it, but the stuff in the tube just goes like that as the waves go past. So if you have two tubes and you push into that one and pull at the other one at the same time, waves go to the end and collide together. There's motion of the stuff all through it. So when your washing machine is running and lights are lighting, there's speed of light waves running on the wires, but that's not the electricity, at least from the definition used by scientists ever since the 1800s, that electrons are carriers of electricity. The electrons sit still and wiggle back and forth. So all the textbooks are screwed up if they're using the word electricity. When you get into the higher grades where they're talking about electromagnetic wave energy going along the wires, that's correct. Or if they say that the charge carriers sit in the wires and vibrate, or that there's a carrier drift velocity that's inches per hour depending on the current, that's correct. But if you're describing the word electricity, which is what I always did as an engineer and doing science museum exhibits, that's where it gets all screwed up, because there's two things in wires. One is this stuff you see here moving, which if you ask Michael Faraday and James Clerk Maxwell and Thomson, the discovery of the electron, they would say that that's the electricity. Power companies say the stuff that goes zoom, starts here, ends up in the light bulb instantly, that's the electricity. Well, it's the difference between sound and air, and it's no wonder that we can't understand how electricity works, because we only have one word for two things, and one of them is like sound and the other's like air. So you think that like air is coming out of your mouth and moving at 700 miles an hour and smashing into people's ears, and you never understand sound if there's only, like, you pick a word like acoustic. Acoustic comes out of your mouth. Air pumps or acoustic pumps fill your tires with acoustic. You only have one word for two totally separate concepts. Everything gets totally twisted in your mind. You have screwed up definitions. So this is the definition unscrewer. And I put the plans for this exact device on the internet, PC boards if you want to etch things. And a science company is selling little ones. They're way too expensive. I get like $1 each from them. For little plastic tubes that got LEDs in them, and you can build circuits and see the electrons flow. So this is the visual electricity device. And I at one time had 10 of these little stripes. And the coolest thing I've seen is building a full wave rectifier, where you make AC with this thing, and then you have the 4 diodes all with the LEDs in it, and it goes out to a light bulb. So when you go back and forth here, the diodes switch, and you see DC going through the other side. And the Boston Science Museum has a couple little pieces of this stuff in their electronics exhibit. But one of the interesting things after having my paradigm totally repaired by working with this stuff is that when I read Tesla's thing, his words are, Tesla's patents and writing, his words come out right. Because what he was talking about, the natural medium, that was before Thomson and the discovery of the electron. The wires are full of the quote-unquote natural medium, and the ground is full of the natural medium. So if you're Nikola Tesla sending power to all points on the Earth with a resonant power system, yeah, you're sending electron waves through the surface of the Earth. When you put a ground rod in, that is the antenna, and the whole thing makes sense. But not if you think that electricity is electromagnetic energy, or if you think that electrons travel at the speed of light through metals. And this is all the bizarre crap that's in all the textbooks. And so Tesla knew what he was talking about. Nobody could understand him unless they had PhD physics degree and were specialists in electromagnetics, because all of the elementary textbooks on up were all screwy.
Basically, your world was turned upside down?
Exactly. Okay, here's some true weird science, but not working yet. We had I have the webpage discussion, Free Energy L list server on my internet site, and I got contacted by a guy who wanted to remain anonymous because he thought that if anybody knew who he was, the men in black would come and he'd never be heard from again. But unfortunately, remaining anonymous, if the guy's a total hoaxer, there's no way to tell, and he has no problem just telling any story he wants to because he can't destroy his reputation. He's just a Yahoo mail address. But one of the things that's on the webpage, has been there for years, is plans for a capacitor that's supposed to put out physical thrust and is made of little squares of tin with little pieces of tin connecting them together. And you stack up about 500 layers of tin and wax paper, squeeze it together, and then the article doesn't really tell what the power supply is. It says use a strong battery. But nobody had ever messed with this thing. It was probably on the website, what was up until 99 is when this guy started saying that it levitated itself. He had built one and powered it with a Van de Graaff generator. He had split it up into 13 wires, the 500 plates, so it was clustered together and you could switch it on, and said you started switching the 13 switches on, and it would, if it wasn't tied down, it would bash into the ceiling. So a whole bunch of people started building it. I don't think anyone has actually built the exact reproduction of this guy's thing, which is the 500, 400, 500 plates, and the clusters of switches, and using a Van de Graaff, not any other kind of power supply. But no one's seen any thrust out of it at all. So I finally got off my butt and started making one. This is only 30 plates tall. So I'm going to do a more careful reproduction of this guy's thing, because other people have tried aluminum and copper. This is the actual tin, which is what the article says. You have to find a source of foil that's made of tin. It's this gloppy, it feels like lead. So when I get up to 500 layers and hook the thing up in 13 sections, I think that'll probably be the final attempt to reproduce this guy's claim that it lifts itself, and if you cut it loose, it'll blow a hole through the wall, putting out like 10 pounds of thrust or so. But I did find out that if you only turn it on a Van de Graaff for a few seconds, it only charges up to a few hundred volts. So whatever's going on, it's not any 50 kV type effect. So this is called the gravity capacitor. There's a whole section on the website if people want to look it up. And my website is www.amasci.com. So there's a section on grav caps. So if the guy's not just telling stories and the whole thing's not just a hoax, sometime someone's going to try reproducing this thing one more time, and it's going to fly through the air and smash a hole in their wall or ceiling. And you wonder if there's inventors out there that are dead, and that's why you never heard about their success. Because they were like this when they turned it on, and it had never worked before, and it went boom! This one is, oops, got knocked over. And I lost my little tiny magnets. There's one of them. Good, good, good. This one's not mine, but it's a really cool toy sold by a physicist. He had a bunch of them for sale on the internet for about half a year. Oh, what's his name now? I'm blanking. Brian Martin? No. Rats. He's on my website. There's a section on toys. This is Diamagnetic Levitation. Let me put it down on something so it stops jostling around. So if you can get that on the camera. And I said, when is he going to make any more of them? And he said the machinist that he works with at the university never wants to see another one of these darn things again, because he had to make them all by hand on a lathe. And hopefully this guy's going to find a toy manufacturer to turn these out with. That's a little super magnet there, and this is just like a little Radio Shack type ceramic ring magnet. And the distance is the distance where the little magnet will be picked up. So if you put the thing on your hand and just lowered it, right when it got to there, that's when it would jump upwards. The two black things up and down, above and below, are not magnets. They're compressed high orientation graphite, which is, I guess you can get it from certain science catalogs. They're unfortunately, if you just buy two of them like this, they're $30 each. But graphite is diamagnetic in the same way that bismuth is, the infamous bismuth alloy flying saucer material rumors. But graphite's even more so. So it's stabilizing the magnet. If you bring a magnet near a diamagnetic material, it repels, and it's a very feeble force, but it's enough to stabilize and make a little energy well, so a magnet can hover. And you could do the same thing with environmental bismuth shotgun shell shot. And this is on the webpage somewhere in the maglev stuff, making your own magnetic levitation. You can buy non-lead shotgun shot. It's all bismuth. Melt it down. We had a guy melt it in the top of a little aluminum pop can, or in the bottom of an aluminum pop can, so you get a little pool of bismuth. And 2 chunks of bismuth, and then you need a stronger magnet higher, because the effect with bismuth is less than this carbon stuff. But here's a floating magnet with no spinning like the old Levitron device. But unfortunately, it's going to still be like $40 like the Levitron. It was way too expensive for the parts involved. Any questions on any of the stuff I went through so far? No, these aren't available, unfortunately. But that'll be announced on my page if the guy finally finds a manufacturer for them. Yeah. Hang on a second. I want to grab the microphone. Yeah.
Just a comment about your infrared glasses. Mm-hmm. As I understand it, the process with fluorescent paints is that they take infrared light that's coming in and transmute it into a visible frequency, adding to the amount of visible light. That's why they appear so bright. So what you may be having there is a transmutation of infrared into a visible range.
Could be, but that would be in your retina, except fluorescent paints, that's ultraviolet. It's like the black lights that shine on it. There are materials that do infrared also, that fluoresce from infrared light.
I would think it might be possible to do that with a clear material as well, rather than just an opaque reflective material. And the reason I say that is that a friend who worked out at TI witnessed a pair of glasses chained to a laboratory table that as he passed through, this fellow said, "Put these on." And he put them on, and he looked right through the wall.
Ooh. I don't have an explanation for that. If once you get used to the infrared darkness with these, if you have a big piece of that infrared filter material, you go outside, it looks dark gray. So you can for regular eyes, this stuff is just totally black. But when you're using the glasses, you can see through the stuff. So if the wall he was looking through was black, it could have been a trick. It could have been infrared filter material. And then looking through the glasses, depending on how they worked, if they were letting him see infrared. A real infrared camera, you look at these goggles, they're just perfectly clear. It just looks like glass lenses, no darkness at all. So they pass infrared, very close to 100%.
Well, he said these glasses looked like you couldn't see through them, that they even had an oily film on them when you just looked at them.
No idea what that could have been.
No, I don't either.
Yeah.
Might have been sodium iodide.
There's a salt of iodide that you can actually make into convex lenses. Mm-hmm. The only thing is it's really subject to moisture in the air, so that oily feeling on that lens may have been the moisture in the air on the iodide crystal. And it will refract infrared light.
A side light on the infrared. I'm going to have Travis point this little infrared remote at me, at the camera. Stand back, Travis, over here. Yeah, that one. Yeah, stand back over here. I'm going to shoot the remote. Watch this. Go ahead and do it. Do you see that on the screen? Push it again.
Oh, push again. There you go.
You can actually see the infrared with the video camera.
Here, shoot it through the goggles. It won't stop it at all.
Yeah, it doesn't stop it at all. Look at that. So you can see infrared with a video camera. I don't know why that is, but I found that out by accident one day. Speaking of infrared. It's good.
But it's not, that one's not designed for infrared, so you can't go to the beach and see if swimming suits are transparent.
You should be careful now with that, because if you accidentally get quite low in that infrared range and hit a gravity wave, you might get a black eye.
Terahertz. It really hurts. Okay, next one I'm going to do one that's actually dangerous. If I have time to power up 120 volts in carbon arc. But this one, you're not going to be able to see anything because you have to look at it with a hand lens individually. But got handouts, a big email from Gene Malov from years back about this thing. This is demonstrating chemical transmutation for real. Anybody can do it. It's really, really simple for a garage hobbyist. And if you don't work with 120 volts, I wouldn't touch it because you could kill yourself. But if you put 120 volts on a couple of carbon rods, I use a 1,000-watt heater in series for a current limit. So the old little kids playing with carbon rods trick is you put a couple of weighted wires in water and then add salt to get the right amount of resistance. Because if you just go like this with a short circuit with no resistance, it'll blow the breakers. But you strike a carbon arc really bright, don't look at it, got to put a little cover over it, and let it make a whole bunch of black crap all over the electrodes for a while. And some of the carbon turns into iron. So for people that want to reproduce this, here's my version. I took a couple of hunks of stock brass and drilled a couple holes in it that are a slip fit on the carbon rods. It made them a little undersized so I could sand the rod down slightly so I could just jam it in. And my simple little circuit here is what they call a suicide cord. Piece of lamp cord, a little AC outlet, and this is just a switch. So I plug my 1,000-watt electric heater, and then I get my rubber glove and my pliers to hold this thing. So when it's plugged in, I'm just turning the heater on and off and striking a carbon arc. So it says, chemical protective, do not use for electrical work. So, do like I say, do not do like I do.
Those of you that are efficient in CPR, stand by.
Let's move everything away from here.
This is real TV.
I've done this 3 times before and nothing happened, so it's got to be totally safe, right? That's what the guy that ran the Titanic through the iceberg said. I hope the other end is plugged in here. Let's see. Yep, it is. So, well, that's what a carbon arc does. If you want, we can look really quick at it here. I don't want to touch the wrong part. Whew.
So let's lay it down and we got it on camera.
So everybody can see. Yeah. So what you do is get a little pad of paper, and I'm going to, well, we could look at it with the camera for a moment, but this makes UV, so we don't want to stare at it at all. And it's probably going to hurt the camera, so we don't want to look anymore. Or you can look at the little spill light. But we just do like this for a while. My little heater's turning on. And go like that for about 30 seconds. And I'm just going to do it quick just to show how to do this. And you'll get little black specks dropping out, and black crust builds up all over the carbon rods. And cold fusion is really going on. This is one of the tests done by Dr. Bakris at Texas A&M, where they were trying to throw him out, and the chemistry department signed a petition to get him knocked out of the department. He's retired now, so he was right at the end of his career, so he could do really unsafe things, and managed to survive right to the end without all the colleagues turning on him because he was doing alchemy. But now that I have the outlet in my hand, so I know where it is, you get some little plastic tool, and I see a little black stuff. I didn't do it for long enough, and scrape some of the black off onto your paper, and then you need a neodymium supermagnet. Let's see if any of these move. Nope, I don't see any moving ones. But what I found works really good is the little supermagnet stacks I was selling, you get a supermagnet and a white balloon for contrast. And this one's all covered with carbon, so this isn't any good. I can find a white spot. So I have a nice, really smooth white on the magnet, and then once you built up a bunch of the carbon crap, and just do it on the rods and everything. Don't touch anything, and to make sure, no, I don't see anything. But you generally can't see it by eye, but with a little hand lens, you'll see little tiny dust motes. And if you move the balloon along, they follow the magnet, and they stick to the magnet, and Bakris had them analyzed in their iron. And these carbon rods that I have right here, I know where the 120 volts is, so I'm going to touch it, are spectrographic instrument carbon rods that have, they're very pure. They've been analyzed with 2 parts per million manganese and about 3 times less of silica. So there's no iron in them. And you can burn a big pile of carbon powder, which is one of the other alternate versions of this thing, and make quite a bit of iron. So you have a little chunk and can take it in and get it analyzed. And you start out with pure carbon and you end up with iron. Not economically useful, but as a demonstration that's going to make a chemist's head explode. Converting carbon to iron on the tabletop, it's a paradigm buster thing. But it's been around since 1994, and there's papers about just this thing from 1961. So that's how science works. If modern scientists weren't insane, it would be like 1900, where Becquerel finds that film fogs. Everybody runs out and tries it. Radioactivity, high energy particle physics revolution happens. So here we find we could convert carbon into iron, dead silence. This has been in Infinite Energy magazine and talked about on the web, and it's transmutation. If you are a professional scientist and start messing with this, you're a cold fusionist, and you're going to get kicked out of the department because everybody knows you're doing crackpot stuff and you've gone delusional. But so the way to do it, if the world stays around for long enough, is you infect the high school students and get them working. Oh, here's just a quick safety note. If you try to do it in a Pyrex container, the carbon rod burning right up against the Pyrex, it goes ting, and then my crack went all the way around, but I can't pop the tube. Oh, there we go. So next, try a ceramic block and see if I can build up some carbon detritus. Oh, this, you can also do it underwater if you don't mind having a cup of water and putting 120 volts on it and grabbing things with your rubber gloves and water and electricity. But you get all kinds of black stuff building up in the water, and then you just stick a supermagnet up against the container, and little black dots will be sucked out of the water all over the magnet. And that's the transmuted iron. Got more time? Am I at the end? Oh, okay. Oh, we can do the how to draw holograms by hand. Oh, here's, where did I have that? There's a photograph for the camera to take a look at. And if everybody was here yesterday, you saw this. Here's another one. This one took me about a half hour to draw. That's a hologram of a little box. Can people see that? Oh, the camera got it? So this one, the point of the box is almost touching the plastic and the rest is a lot deeper. And if I can find it quick, I have, I made a pyramid. Here we go. When you see the pyramid, you mostly see the triangular base. The three lines come up. So true hologram, the point of the pyramid extends out through the plastic into space by ½ inch. And people could come up and take a look at this in the spotlight afterwards, because you really have to hold it in your hand to get the full impact. And to make these, you need a piece of clear plastic, or a piece of plastic. Doesn't even have to be clear. I just use black plastic, but you can paint it black, and that's just for contrast. And some professional dividers. They're about $10 in an art store. And you want not pencil, but you have to replace the point with the little sharp points that come with them. And to draw a hologram, you take your piece of plastic, if we can zoom in on this, and you put your dividers on it, and if you want to have a glowing dot that's right there and sunk in 3 inches deep, well, you set your dividers to 3 inches, and then you scribe a scratch like that, and you've drawn a hologram of one glowing dot that if you go out in the sun and look at this, you'll see a glowing dot that's floating deep, because the scratch returns sunlight. If here's your two eyes in 3 dimensions looking at it, the scratch returns sunlight, so each eye sees a reflection from a different place, and it seems like it's comes together back here 3 inches deep. So to scratch your own holograms, you draw them one dot at a time, and what's easy to do is write a letter right here, and then put the dividers. Let's get rid of all this other stuff. Put one point of the dividers on a spot on the letter and scratch it, and then move it down, put it on a spot on the letter and scratch it, and just keep going all points on the letter, and you get this mess that looks like sandpaper. And then you go out in the sun and you see glowing letter A floating down inside. You know, write your initials or nasty secret messages or whatever. And if they're set to 3 inches deep, that's how deep it'll be. And then afterwards, break it off. So the clue of how you did it is gone. All you have is the sandpaper scratches. And that's what all these things are. If you take a look close at them, some of them have the little diagram at the bottom, and some of them I've sawed it off so you can't see anything. But this is on the website as well for a project for kids to do. See if I have any other worthwhile ones to look at. This is a box with made out of stars with a glowing triangle at the bottom. Can anybody see that? Oh, let me look at the screen. I'm trying to get the audience to see it. Oh, there it is. I think the white, there it goes. Yeah. 3 dimensions. It's a box made of stars with a triangle at the base. So that probably took about 3 hours of scratch, 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 scratch. But the first one I ever did was on vacation, sitting out at the dock, watching the geese take off in upstate Vermont. So that's where you can spend 3 hours, and it's you don't care about how long the thing takes. And I've come to the end. That's it. So if people want to come up and take a look at things close up, we can do that if we have a little bit of break time. Oh, pop bottle. bottles. I forgot pop bottles. Yeah, I had this set up over this morning in the area over there. This is not weird science. It's conventional. It's from the Ben Franklin era. Of course, he didn't have pop bottles. They had to use carefully balanced glass parts. It's a motor that runs off of voltage. It's based on capacitors and direct electrostatic attraction rather than on coils. So it's not a electric magnetic motor, it's an electrostatic motor. And I've got one of these little power supplies that I had over at the table. This particular one barely turns over at 5,000 volts. So I hook up my high voltage supply, and plus goes to one pop bottle, minus goes to the other. Is it close enough to touch? There it goes. Oh, that's scraped. And I've got this on the webpage as a kids project, and I knew I'd become successful when I heard mention of a school that for kids' science fair, they wouldn't let the kids make baking soda volcanoes. Because you have a science fair, you get 70 baking soda volcanoes and 3 solar systems made of paper mache. So they banned solar systems made of paper mache, and they banned baking soda volcanoes, and they banned pop bottle voltage motors. Because otherwise, everybody just does pop bottle voltage motors for their science fair exhibit. But if you don't know any electronics or have access to a Van de Graaff or anything, somebody reported that you could put a piece of aluminum foil on your TV screen and clip a clip lead to it, and one goes to the TV screen, the other one goes to ground, and every time you turn the TV on, it runs for about 20 seconds. Then you turn the TV off, and it runs for about 20 seconds. So safe high voltage power supply. And if I really push things, I can say this is part of the Test Statica Methertina device, that it's got a big electrostatic motor as part of it. But I think that free energy device you could power in all kinds of ways. He just probably had high voltage DC available as part of its operation and had it self-acting by having an electrostatic motor push it. But the current through this thing is way less than a microamp.
Gotta be over unity.
Yeah. But at maybe 10,000 volts, so microwatts. So I can run it going through my body. There it goes. I can't feel a thing, but then you can't feel, it has to be like a milliamp before you feel anything from a battery. And when I've got a, well, let me try it. When I have a Van de Graaff, I can run it through the air.
Is that acting as a solar collector?
I'll set this really close. Hope it's touching. I'm going to try to run it through the air. I don't want it to touch there. With needles. So we get some ion wind going. There we go. So the needles are shooting out charged air, and it's being collected by the aluminum in the pop bottle. So there it's running its quarter of a microamp or whatever through the air. And you could do the same on the other side and have the thing run with a Van de Graaff generator. You could put it over here with a needle pointing at the motor and have a hoax for energy device, because it'll just take off really fast going. And you can put your hand in the way and it'll stop. So it's a burglar alarm that's an ion beam. Ooh. And there's a lot of other conventional science, fun science stuff on the web page, and the section called Not Your Average Construction Project that's got all the weird stuff. So that's the one where most of them are untested, and a lot of them, the majority, aren't going to work. But there's free energy and anti-gravity test devices on that section. And the webpage is www.AMA-SCI as an amateur science, or search on science hobbyist. Or weird science. And that's it. Oh, questions. We have some time. And the people are interested. I have maybe like 50. So if you're serious, come and grab one of these.
Come on up to the mic for the question.
Gene Malov's big info email on carbon transmutation.
Yeah, I have a question. Have you figured out what to use instead of carbon so you can get gold out?
There's a group of people in Seattle making gold, and the big downside of that is this is the Joe Champion process, where you mix a bunch of stuff that's related to gunpowder and ignite it in a coffee can outside, and it burns down, makes a big cloud of smoke. And in the detritus, there's tiny little specks of an alloy that's got a lot of gold, platinum, silver, and various things. And you can make a living off of this, but it's just like a good job, because you can't make 2 coffee cans worth. Nothing happens. So they can't scale it up. And that was the problem with what Joe Champion was doing. So there's people that they're just out in the backwoods selling gold, and you can use electrochemistry to separate the gold out into pure gold crystals with an electroplating process. But it's true transmutation because there's no metals in the material except tiny traces of seed element that you have to scrape a little bit of pure gold into it, and then you get like 100 times more back out again. But for the amount of labor you have to do to get the stuff and then sell it, it's just like having a job. You can't become a billionaire on it. But that's the one they're using, I think, is in the Joe Champion book, one of the recipes. Oh, except I think there's other people that developed that Champion was a latecomer, from what I hear in the whole rumor mill. Questions?
It's good.
Okay.
Hold on 1 second. Hold on, we have some changes.